So Megan's on a Ferris wheel, diameter 193 meters. So what would I label on my diagram here? Is my maximum 193 meters? Well, let's keep reading. She gets on 15 meters from the ground. So this is 15 meters. So does anybody, so you're not 193 meters high, you are 208 meters high. And my min is, what's my min? 15 meters. What's my median? Oh, I thought I was going to change this so that it actually divides nicely, but it doesn't matter. Anyways, 208 and 50. How do we find the middle? Yeah, max plus min divide by 2. So, what is it? 208 and 15 divide by 2. 111.5. Okay, what's my amplitude? What's my amplitude? Yeah, you know what? You could subtract the 2, or what do you know about the diameter? Huh? The radius is half the amount, right? So if you knew what the radius is, it's just 15 plus that, right? So, or sorry, the radius would be where it is. So, but anyways, I can do it this way. So that's a 7. So that's 96.5. Yeah, I could have halved it, right? Okay, so has everybody got this so far? Okay, the problem now is I got my A, I got my K. How do I know what my period is? Yeah, it says it completes a rotation in 20 minutes. So my period is 20 minutes. So what would my B be? It doesn't tell you what the time would be, and sometimes they break down the time. They'll say it's in minutes or it's in seconds. But anyways, what would my B be then? 2 pi divided by 20. Does everybody see what would be pi over 10? Yeah? Okay, so I got my B, I got my K, I got my A, I'm missing my H. The thing is you got to read the question, and it says she gets on 15 meters from the ground and completes a rotation. So she's starting here and then going one rotation. Do you see that? So let's do the sketch first versus the equation. We're starting the time when she gets onto the Ferris wheel. Does everybody see that this would be a 1-quadrant graph? And we have our height, h of t, and our time is t. My period would be 20 minutes, so that's my 4th tick. Do you remember how to do this? Okay, so now on these word problems with the height, it's probably better to do broken graph. The reason why is because you'll probably lose marks on your scale otherwise, because if you start at the minute is 15, that means you have to go up by 15s, and you can see very well that how am I going to graph 111.5? Well, all you have to do is do a broken graph, have the middle as 111.5 and the top as 208. What's my scale established? It's going up by 96.5. Do you see how to work it? So broken graph, do the min, the median, and the max, and it's good. If you don't do a broken graph, you'll lose marks, of course, because the scale is not correct. Okay, so if she gets on 15 meters in the ground and goes for one rotation, does everybody see? She'll be at the lowest point, and then a period later she'll be at the lowest point. What would be halfway between the two lowest points? The highest point.
Yes.
So this looks like a beautiful coast graph, right? Yes? I didn't hit that one dot there. Okay, so what's so nice about this cosine graph? It's just a reflection, right? There's no shift. You could say it's shifting over there, but why wouldn't you just pick this one and do a reflection, right? Okay, so it's going to be negative. What's the amplitude? 96.5 cos. My b is pi over 10 t. The thing that people have trouble with is they're so used to using x's and y's. If we change the variables to h's and t's, we get a little bit confused. And then, what's my k? Plus 111.5. Does everybody see? There's my equation of this Ferris wheel. Yes? Okay. Here's another word problem. Here's the hours of daylight per day in a calowatt. It shows the number of day hours N against the day of the year T for a calowatt. This graph approximates a sinusoidal function whose equation can be determined. Find the sinusoidal function. What assumptions did you make? So that's how they can predict things in the future, by graphing them, right? Okay, well, we got to come up with the equation here. So what's the max? What's the min? We're going to be approximating, right? It looks like my k is 12, yes? What do you think that is? Min is 3? Okay. That means I'm going up by 9. So then this would have to be 21. Does that look like a 21? Yeah. Okay. What assumptions did I just make? I assume max is 21 hours, median 12 hours, and min 3 hours. If you put that as part of your assumption, you can't mark it wrong, right? What else am I going to have to assume? Well, first off, I did just say that A is 9, right? What's my period here? This is day of year, by the way. Even though they have months listed, they didn't start with day 1, day 2, day 3, day 4. They did it by months just to make it easier looking. What's the length from here to here? How many days would that be? Yeah. So period is 365. So that's my assumption is I assume period is 365 days. We're not going to put the quarter in and all that stuff. Okay, so if the period is 365 days, what's my b going to be? 2 pi divided by 365, right? Okay, so what kind of graph do you want to do? What do you think it's set up to look like? A sine graph, yeah. So let's just do sine. There's no shift then, right? Okay, so it does say we have to use n and t. Does everybody see that? N is the number of hours, and t is the day of the year. So is it going to be n equals or t equals? Yes, n. N equals what? 9 sine bracket 2 pi over 365 t plus 12. There you go. There we go. Easy as that. Pedals on a bicycle have a maximum height of 30 centimeters above the ground and a minimum height of 8 centimeters above the ground. Out for a ride, cyclist pedals 20 cycles per minute. Maybe we should get Matthew to solve this one since he's a cyclist. Okay, let's draw a diagram. I'm only going to draw one wheel. The pedal will be here, and the pedal will be here, and the pedal will be here, right? In the middle. I guess the pedal's not really at right there. It can't be, because otherwise you'll hit the ground. So we'll just say it's like that. The wheel is above the ground. How about this? How about I make the tire thicker so then it looks like it hits the ground? There you go. That's much better, hey? It's a pedal. Those lines are the pedals. Okay. I'm glad you think it makes sense. Okay, maximum height is 30. And the minimum height is 8. So what's my median? 19. How do we get that so fast? Add them up, divide by 2. Right? Okay, that means my amplitude is 11. It says that there's 20 cycles per minute. I'm going to write that out. 20 cycles per 1 minute. Is that pretty fast? No. What do you do? Can you actually calculate it? Oh, you can calculate just about anything in this day and age, right? Okay, so they're saying 20 cycles in 1 minute. The problem is 1 minute, we need to actually have it written the other way. We need to know how many, the time per 1 cycle. Does everybody see? So if I have 20 cycles here and 1 minute, I'm going to change this to 60 seconds. Why am I changing to 60 seconds? So then I can see it much easier. What does that mean? It's a 3-second cycle. Yeah, that would be slow, hey? 3 seconds? If you think about it, 3 seconds to do 1 round. Yeah, you're kind of just coast. I don't know. Okay. Anyways, does everybody see what I did? So that's my period is 3. So what's my B? 2 pi divided by 3. Okay. It doesn't tell you where we should start the pedals. So we'll ask the expert here, where do you usually start your pedals to start biking? At the top, at the middle, or the bottom? I would say top too. That's what I think. And you know what I like about top is it's a cosine graph if you start at the top, right? If you start at the top and then you go down, do you see that's a cosine graph? Yeah. And there's no shift. We like it. Okay, so the height is equal to 11 cos 2 pi over 3. We're going to say t for time. T plus 19. It was as easy as that. Actually, the word problem is if you can get it so it's set up like this. A lot easier, isn't it? You're sitting on a pier when you notice a bottle bobbing in the waves. The bottle reaches 0.5 below the pier before lowering to 1.4 below the pier. The bottle reaches its highest point every 5 seconds. So here is the pier, say, And then here is the water height. That's not a very good diagram. I'll try again. Here is the pier, and here is the, say, the water level. Water. Yeah? This is the pier. There is big things holding it up. Because think about it, the water isn't at the pier level. Otherwise, as soon as a wave happens, it would be crashing onto the pier all the time, right? When you're walking on a pier, it's quite a few, like if you actually go on a pier, like if you go to Navy Pier, like, you know, you said you went to Chicago and you went on that Ferris wheel, I'm sure you went on a pier, so, okay. So it's saying the bottle reaches, so I guess what we're trying to say is this is level 0, right? And it's saying it's going to negative 0.8 meters and it's going as low as negative 1.4 meters. Does everybody see that? Because the water in the middle, below the pier, right? Do you see why it's negative? Nope. So here, now we can see how this is happening. It's going above, below, the bottle is bobbing. It's getting as high as that, as low as that. And when there is no waves, it's at the, whatever the level that is, right? So what is that level? Add them up, divide by 2. What do we get? Huh? Well, 8 and 14 is 22. 22 divided by 2 is 11. So it'll be negative 1.1 meters, yeah? Yes? Okay, so what is my amplitude here? .3 meters. Remember, it's length, so it doesn't matter about the negative. Yeah? Okay, so we got the A, we got the K. What are they telling you here? It reaches its highest point every 5 seconds. That's the period. So B is 2 pi divided by 5. Yes? Okay, we got my B, got my A, I got my K. What are we going to do? Should we start at the highest point? We're going to start at the highest point and say, I assume we start at highest point, because it doesn't say. There you go. Made my assumption. Now we can't be wrong. Okay, so H equals. What is it? 0.3 cos bracket. What? 2 pi over 5 t minus 1.1. Beautiful. There we go. Bottle bopping. Okay, now we're at tides. This is a graphing calculator question. Did you understand that the graphing calculator imposes a bracket somewhere in this equation? It's not written nicely. But it imposes a bracket right here. Does everybody understand that? So where do I need to close my brackets? After the other bracket, right there. Does everybody understand that? Because the t minus 1.5 is the shift to the right. It has to be inside that first bracket. And we have to be in radians. How do I know it has to be in radians? Because you guys are that good? No, because it's saying the b is 0.164 pi. Okay, so let's grab our graphing calculator and graph this. So in order to have the best viewing window, you need to figure out what your max is. It's 13.4 plus 2.5, so that is what? 15.9, and what's my minimum? I'm sorry? Yeah, 13.4 subtract 2.5, and what do we get there? 10.9? Is that right? Okay, so now go to your viewing window. Good. Let's figure out our periods so that we can actually see how long we should have our x's. How do I figure out my period? 2 pi divided by 0.164 pi. The pi's cancel, and it's whatever 2 divided by 1.64 is. Who can tell me what that is? I'm sorry? What is it? Approximately 12? 12 point what? 1951? Okay, so use your period to guide your x. Use your max and your min to guide your graphing calculator for you to see stuff. Okay, so we're using our window settings to see it, because that's going to happen a lot. Okay, it says if a cruise ship needs at least 12 meters of water to safely dock, for how many hours per cycle is it safe to do so? So remember what this was? What was my minimum? 9.5? So this is probably 10, 11, 12. Does that sound about right? Where am I looking to safely dock here? Everything above. Does everybody see? A cruise ship comes in. This is the level of the water. If it's below this, it's not safe, right? So you need to figure out what that spot right there is and that spot right there, and then the length of that will be how much it is safe. So who knows how to do this on a graphing calculator? Well, I drew this line. How could you get that line? What's the equation of that line? Y equals 12. I'm putting y2 because that's going to be on my graphing calculator. Y2. Okay, so after I've done the intersection of those two spots there, what did I say I have to do to find how long it is for it to be safe? I have x is 0.346 and x is 8.751. What do I do? You subtract. So 8.751 subtract 0.346. You can use your calculator if you want. So that is what, 504. And what does that represent? 8.405. That would be how many hours it's safe. Whoops. So, word question. Let's write the word answer. It would be safe for approximately 8.4 hours each cycle.